All right, so since we have the data from the DIA and the SRM dataset, so one question we may ask would be, so how correlate or what's the agreement between those two datasets? And we'll evaluate the agreement based on the correlation of their protein quantification results. All right, so for those two tests, we'll discuss those tools in Tidyverse. And in particular, we want to learn how to tidy up a messy data set and do manipulation and transformation of the data and carry out the notion of split, apply, combined approach that we discussed yesterday. And finally, we'll learn how to combine or join data set coming from, well, for example, in this case, we have data set from the DIA technique and the SRM method, and how to combine the result together. All right, so I will go back to right. All right, so by typing the library Tidyverse, it would load 8 core package of in the Tidyverse. So Tidyverse is essentially a collection of the R package that, well, they share common data representation. Essentially, they are built around the tidy data that are stored in Tibbles that I will talk about shortly. And they also share some common design principle. And the best place to learn more about the Tidyverse would be the website of the Tidyverse, which is the tidyverse.org. And I provide an article written by Hadley talking about some design principle in the Tidyverse. So essentially, I think the key message there would be, so they want to design or develop a tool to make it simple, to make it simple and to do some minimal work, but try to do those work nicely, very efficiently. And also to make those tools that can be easily combined with other tools, so that when we try to build up a more complicated process, we can easily to build those operation based on those available tools in Tidyverse. And essentially try to combine those tools in a easy way. So, as I just mentioned, by loading the meta package, so you are going to load 8 core package here, ggplot2 for data visualization, Dplyr for essentially for data transformation and manipulation. Tidyr would be for the how to tidy data, and also some tool for the data import, the readr. And also we're going to talk about how to do the statistical modeling, and the Perl would be the very good, would provide a very good tool set for us to do the modeling and the testing in an efficient way. And also there are some other tools that are designed specifically for some specific data type. For example, the string R would be used to process the string data, and the forecast would be specifically for those categorical data that's vector in R. And so today, in today's section, so we'll be mainly focused on the Tidyr and Dplyr. So essentially, if we look at this diagram, that's somehow give us a high level representation of the task in data analysis. So essentially, starting from the getting your data, import your data, and tidy up your data, and through some data transformation and visualization, and also some statistical modeling, we become more familiar with our data. We understand more about our data, and then we can communicate some insight and finding with our collaborators. So today I'll more focus on this part, tidy data and also data transformation. And in the section in the afternoon, so we'll talk about more if we want to fit more model and what would be the good way to do that. Go back here. All right, so in Tidyverse, there are a few quite helpful conventions that we can use. So the first one I want to introduce is the Tibble. So Tibble, by using Tibble, is going to create a Tibble object from an existing data frame. So let's say we load the data already, and here in the twin DIA, it's a data frame as we just talked about. And by using a Tibble, that's going to create a Tibble here. And Tibble are just a special data frame, but it has some enhanced or better print method that shows the content nicely on your console. So for example, if we just type the twin DIA here, and you'll see it just shows the first few rows of the data frame, and it's not going to eat out the space of your console. And also it shows nicely those columns that can fit into your console. And another thing I want to introduce is the pi operator here with this sign. So it's quite useful, and it's a way to help us to train or to combine the multiple operations. Say, for example, so let's first talk about what it means. Now, for example, if we want to apply the function on the x object here, and with some additional argument here, and it can be it can be written as the x, which is the object we want to operate on, with this function, and with some additional argument pass on here. So by looking at this may not be quite useful, but once you try to train multiple operation, then things can be quite nice. So for example, here we try to combine two operations, function 1 and function 2. And the first step we'll do will be we apply function 1 on x here, and with some additional argument y here. And the returned output will be used as the input for function 2 here. And this is again the nested representation that we talk about. So here it involves two steps of the operation. However, if we want to essentially to know the flow of the operation, we'll need to read from inside to outside, and it's not very straightforward. But if you use the pi operator here, so it makes things the workflow very clear. So we'll start from the input here, that's the x, and apply first function y here, and the output of the function 1 will be the input for the function 2. So that makes each step, the whole workflow and for each step very clear.
Can you also chain together like vector operation instead of functions? Does that work as well?
Vector operation?
Yeah, just like if you wanted to like subset something and then take that subset and do something with it. So,
yes. Yeah. So I think we are going to talk about some function to subset your data, either for your row or for your column. And And definitely, so the result of that function will be the subset of your original data, and then you can pass on to the next operation.
Okay, but that's still using the function to do that.
Yes.
Okay.
Yeah. Okay, and it's just well for the convenience of you using this Pi operator. So if you are using Windows, well, if you are in RStudio, that would be the shortcut to get this for typing this Pi operator. And if you are with a Mac, that will be the Command Shift plus M. Okay, now let's talk about the idea or the concept of the tidy data. So as I just mentioned, the Tidyverse, the package in Tidyverse, they are built around the tidy data and restored in the table. And so what is a tidy data? So when we say a data set is a tidy, that means each variable is saved in its own column. The variable here can be, in our case, can be protein, can be peptide, intensity, that kind of thing. And each observation is saved in its own row. So here, as we have here. And each type of the observation unit is restored in a single table. Say, for example, in our data set, our basic unit is essentially the integrate peak intensity from LCMS data. So you don't want to mess up this type of basic unit with, say, for example, other measurement like temperature or the height, that kind of thing. So why we need to have a tidy data and why tidy data is good? So the reason we want to organize our data in a tidy format is because it makes it easy to assess your variable in a tidy data set. So every time you want to assess a value for one variable, you can just go ahead and to extract the value from one column. And at the same time, if you want to make some operation on multiple variable, then it would reserve. For example, here you want to create one additional variable, which is multiplication of A and B. By doing that, R would automatically reserve the case during this factorized operation. So that means it's easy to get the information, get the variable from your data set, and also at the same time when you want to do the transformation and manipulation, and those cases would be in the same place, so you don't need to worry about how to extract those cases at different phase of your process. So any question for this concept? Okay, and that's then talk about, so now we know the concept of the tidy data. So the next question will be, so now we have the two data frame, twin DIA and the twin SRM. So are they tidy? So I'm going to just to create a subset of the twin SRM data set. And so I'm going to create a subset for just 2 proteins and 3 samples. And with a few different representation, and we are going to look at each of them and discuss whether or not they are tidy. So I'm going to. So let's first look at the first case. So in the first case here, essentially we have 2 protein and 6 features, so three per each protein here. And we have the intensity for R001, 002, and the 003 for the heavy channel. So the sub 1A here would be the subset for the heavy channel. And we also have another data frame, sub 1b, with the same arrangement. We have 2 protein, 6 feature for 3 runs, but those in intensity are for the light channel. So, can anyone tell me whether or not those 2 data, whether or not they are tidy? They are not. So, any reason for that? Right. So you are talking about we have 2 types of intensity, light and the heavy. So they should be should be put in the single data frame. Yes, that's correct. And some other reason. Another reason is, so here let's look at the row name here, R001, 002, and the 003. And if we, let's go back here. If we think about one observation, and what does one observation for LCMS data means? So you probably means it's a peak intensity in one sample, right?
For example, you can sample have 100 protein, and every protein measure the value.
Right. Right. So one observation will be in one run, right?
In one run, yeah.
Yeah, rather than multiple runs. So now let's go back here. So here in this row, we actually have the measurement for 3 runs rather than 1 run, right? Because it's a measurement for run 001, measurement for 002, and measurement for 003, right? So let's go back here. So if we say each observation should be saved in its own row, in this case, other than the issue we just talked about the light and heavy, if we just look at the heavy here, in one row here, actually it contains 3 observations rather than 1. And the row name here, the R001, 002, 003 here, well, in this format, they are actually the column name. However, they should be arranged as a variable here, as a value for a variable here, as an indicator for those peak intensity, where those peak intensity come from. So we'll talk about how to address this issue and how to tidy up this messy format. And let's then look at the second way of the representation. And now again, with the same information, and we have again the 2 protein and the 6 feature. And this time we have the run. We have one column called run as an indicator for those feature intensity, run 001, 002, 003. And we also have a label column to indicate whether those intensity are from the heavy channel or light channel. And okay, so then for this data frame, so how would you think? Is they tidy or not? Is tidy?
Maybe.
Maybe.
Because run is not a variable. It's like it's part of the name of the observation.
Name of the observation.
Yeah, run is what is being observed, not what being observed. Run is, I don't know, it's part of what characterizes a sample.
Right. So that's probably a variable to characterize your feature intensity, right? So I guess for sub 2, people may have different opinion on whether or not it's tidy. So lots of people are saying, okay, it's a tidy format because in each row, essentially that represents the peak intensity in one run, right? For example, here in this first row, it means for this protein, for this feature in this run, and in the heavy channel, and that's the peak intensity here. So if you actually view a peak in the LCMS map as one observation, so this representation is tidy.
You could also have a light intensity, heavy intensity, and that would be two different variables.
That's right. So that's exactly what I mean by the second bullet. So say if you instead of viewing this one peak as the basic observation unit, if you think, okay, one feature in one run is actually your basic observation unit, and that basic observation unit is measured with the light and heavy. That's exactly the same way. Go back here. We say twin DIA. That would be the way we organize our data in the twin DIA and the SRM, where we have the light intensity and the heavy intensity. And if you view one feature in one run as the basic unit, then this representation is not tidy, because right now you have your observation scattered across two rows, right? Yes?
And you have here a DIA dataset, and you will not find all transitions or all fragment items over all runs. So would you then list for all runs the fragments again and give FA values, or would you just leave them free? Or you could also make columns for every fragment, basically, and then write values.
Yeah, so the way of your the way of the representation that you talk about is actually, say, for example, you have a protein, you have the feature here, and if you want to restore the intensity in every run here, and so you may have some NA here, etc. And this type of representation is sometimes called a white format, because essentially you are catenate your runs, or catenate your.
You have then one column for the B4 ion, one for the Y6 ion, one for the Y7 ion.
Yeah, so I think this one is the getting closer to a tidy format, because the white format, as we just discussed, every row does not really correspond to one observation. It represents actually multiple observations essentially in different runs. Right. Yes.
So then with fragmentation, like you said, would you want to go wide or would you want to go down?
Yeah, so if you want to organize your data in a tidy format, then you want to have a tall format. Is it called tall? Yeah.
But if I want now to extract the information of the B4 ion across all runs, how can I do it there? Because I would just leave away the entries in the runs where I did not find the B4 ions.
Yeah.
Missing values for that.
Hold on that question for 1 second, and yeah, we'll get to that very quickly. Yeah. Okay, so yes.
So, this might be a more high-level question, but why would you want to have your data organized in the tiny format? Because to me, it seems harder to kind of evaluate your data that way. Like, I can't really compare two things because they're so far apart.
Yeah, so there are a few things. So the first thing is what we just talked about. If you organize your data in a tidy format, then it makes it very easy to extract the meaningful information what you want. And like you say, okay, if now you want to look at certain, say, ion, certain fragment in different runs, in that case, you can still, from the tidy data, you can still to spread those information in the wide format. But however, what we are really looking for here is actually a way to do the manipulation and the processing in an efficient way, in a consistent way. And after that, when you want to look at the summary, you can always going back and forth between the tidy format and the wide format. Yeah.
Can you make a 3D tibble?
3D table? I guess no.
I know in other programming languages you can make n-dimensional arrays. In R, if you want to do that, you have to like make a list of arrays. I've always wondered what that was.
I think there are multiple dimension array for table.
Yeah, you can make multi-dimensional arrays in R. That's fine. But data frames are specifically designed as a 2D data structure with heterogeneous columns. So you can have multi-dimensional arrays. That's fine. But just data frames are defined in that specific way as tabular data with heterogeneous columns.
Okay. So we just had some discussion about whether or not the sub2 is tidy or not, and definitely we have some different opinion about just based on the way we define the basic observation unit. And so for the sake of discussion, so we'll take the second view here. So we'll view a feature in one run as an observation. So that means we'll have two variables for the intensity, one for heavy channel and one for the light channel. And we can have yet another representation here, the sub 1 and 2. And this representation is actually sort of the combination of the two issues. So we have the one issue here where the run ID here, they are restored in a column name rather than a single column. And also for one feature, they are scattered across two rows here. And also here's another way to represent the data with the same info here. So we may have one protein here, feature here, run here, and well, sometimes people may want to have a single column to represent everything they would like. So for example, they may say, okay, we have a column called intensity both, one for heavy and one for light. And yeah.
Would you be able to plot with that format?
You mean plot?
Yeah.
You won't be able to do that because first of all, this one, I mean the variable here is a character. And so if you want to use the numerical information, you will need to first to convert, two things. So you will need to first to separate the info for the heavy and info for the light, and also to convert to appropriate type of the variable. Yeah. So we'll talk about that actually. All right. So we just look at different representation for the same. Essentially for the same data, and now let's say we want to organize our data in the tidy format. So what would be the way to do that? And Tidyr here, part of the Tidyverse, is a package that helps us to reshape or reorganize the layout of the tabular data set. And there are four major functions that can help us to essentially to address those issues that we just talked about. They are gather, spread, separate, and unite function here, and we'll just look at each of them one by one. So the first one I want to talk about is the gather function. So essentially, it would help us to address the issue in the first case. So the gather function, it would move the column name here. So for example, here we have R001, 2, and 3. To move the column name here into a key column. The key column here means the key for the run ID. And also, this function will gather the column value here. So those value will be the intensity value into a single value column. So let's see. So let's look at one more time. That's the original data frame. We have protein feature and the intensity for the 3 runs here. And by using the gather function, we use the gather function apply on the sub1a data frame here. And we'll assign, well, we will define a key column named the run here as indicator for run 001, 2, and 3. And a value column as the intensity h. And for those value, where are those value in the value column come from? They are from the 3 column here, R001, 002, and 003. So those will be the value that we are going to gather into the value column. So by using this gather function, that would transform the format in this way. So now, instead of having 3 intensity in one row, now we have 1 intensity in the heavy channel in one row here. And we just talked about the pi operator. So we can also, essentially that would be the same way to call this gather function. So instead of to have this data frame inside the gather function, we can use the pi operator with the input here in the first place, and then pass over through this pi operator and use this gather function, and then we need to define the following, the rest of the argument here, the key and the value, and what will be the column that we want to gather their value. Yes?
Why do you do this?
Which one?
Oh, never mind, sorry.
Aye. Any question about the gather? Okay, so let's look at a few more examples. So here is just one way to define the column that you are going to gather. So here is because we know their column name R001, 002, and 003. But it's just a subset of our original data frame. Let's say in the original data set we actually have 232 runs. And if you are going to use this way to inform the function of which column to gather, then you need to type from R001 all the way to R232. So that will be a lot. So there are some other way to inform the function where to gather. So one way to do that would be you can use the numeric index. So for example here, essentially you want to gather from the third column, column 3 to column 5. So you can say I want to do the gather from column 3 to column 5. That will give you the same result. And I think you can also use the column name. And that will do the same thing for you. So either the column name, essentially the column name define the left-hand side and the right-hand side of the range, or also the index. Alternatively, you can also to define with those columns that you want to exclude. So here, those 3 columns are the one you want to gather, and you want to exclude protein and the feature here. So you can say, essentially with the same syntax here, but in the end you say, okay, I want to get every column, but other than except for the protein and the feature. And that would do exactly the same thing. All right, so if we now go back to the issue with the sub 1a and the sub 1b here, so we talk about, so first of all, originally it's in the Y format, so we now know how to transform the Y format into the tall format, long format. And now the second thing will be, so we know sub 1a is just for the heavy channel, and sub 1b is for the light channel. So we need to first to transform both of them into the long format, and then to combine the info from both data frame. So that's what we'll do here. So for the first one, we'll say, okay, we want to gather the sub 1a with the syntax we just learned, and then assign the result to Tidy1a here. So Tidy1a, we just look at this, and similarly apply the same function for sub 1b, and then we merge. Remember, we learned about the merge function yesterday, so we'll merge the result. So that would be the format that we want to have as a tidy format here. Okay, so that's a gather function. And the second one I want to talk about is the spread function. So spread function is actually spread and the gather, they are kind of complementary. So gather, we try to gather the value from multiple columns, and now in the spread function, we essentially move those unique value in the key column onto multiple column names, and spread the value spread those value in the value column to their corresponding columns. So here, for example, in the sub 2 data frame here, and we just talked about it was not tidy because we have one observation scattered around 2 rows here. And so what we want to do is actually to move around, to move those intensity spread those 2 intensity into 2 columns, one for heavy and one for light. So we need to also to move those variable in the label column here as an indicator of whether for those feature intensity. So here the syntax is very similar to the gather. So we'll do the spread here, and then we'll define the key column here as a label here, because that will be the key we'll use as an indicator. And the value column and the intensity column as the value. And that's going to transform the original format in sub 2 into this one. So if we compare the original format here, so we have one observation scattered around 2 rows here. And now after applying the spread function, they are back to their correct location, one in the heavy column and the one in the light column. Is there any question about the gather and the spread? Okay. And we just talked about, so in some case we may they are actually the mix of the 2 issues. So we have a white format here, and at the same time the observation is scattered around multiple rows. So we'll need to use the combination of both the gather and the spread and to tidy up this data. So the first step we want to do would be we need to gather those values in our 001, 002, and 003 into a value column. So now we'll define the key column as strength and the value column as intensity. And the value we are going to gather are coming from our 001, 002, and 003. So now we are getting closer to the tidy format. So that would actually be the one that we discussed whether or not it's tidy, the sub2 case. And after that, we need to do one more thing. That would be to spread those two observations into their corresponding location. So now here, I would do first the gathering operation. And then I will use the pi operator to essentially to take the output of this gather function as the input for this spread function. So now from here, by applying the gather and the spread, then we transform the data into this format. And the last thing I would do is to, well, we'll talk about the rename when we talk about Dplyr, to rename this column name as intensity H and intensity L. So that would be the tidy format we want. Okay, now let's talk about the separate function. So in the third case that we just look at, here, the sub3 here, we have one column here called intensity both, and it's a mix of the intensity from the heavy and the light, and also, well, it's restored in as a character. So we can use the separate function in this way. So we'll say the column we are going to separate is called intensity both. And we want to separate this column into two columns. The first one is called intensity H. The second one is called intensity underscore L. And we also need to define a separator here as a slash. So yeah, so by doing that, you essentially to take the left-hand side of the separator into this first column, into the intensity H, and the right-hand side of the separator into the intensity L. Yes?
So if you had some cases that had two, let's say one separator and some that had two separators, and you asked it to separate, would it give you the two columns and just put NA in the third column? Like if you had a variable number of separators?
So the same separator or different separator?
The same separator.
The same separator.
But in different observations, you might only, so like one might have some number slash another number, and one observation might have some number slash another number slash another number.
Well, I'm not sure it'll be an A or not. Let's try it now. So say we have sub3 here, and let's say I change the first one let's say this way. Okay, and And let's do the same thing here. Yeah, it's not. So it'll just be an empty. Yeah. Right, and we have different way to define the separator. So we just talk about the way to, well, to use the character to define the separator, and you can also use the numeric number. So you would interpret it as the position that you want to do the separation. That can be 3 or 4. That would means the index or the position of your string. Okay. And okay. Get back to the side is back. Okay. Okay, now we just talk about to use the separator to separate the intensity both column into one for heavy and one for light. But the output here, as you can see here, the type for the intensity H is actually a character, and same for the intensity L. However, they should be the numerical value because they are essentially the continuous feature intensity. So when you do the separate operation, you can also include one option here to whether or not you want to convert the type of the variable after the separation. So here, if I set it as true, then you'll see the type of the variable in the intensity H and L, they becomes integer here. And the reason here is because we don't actually have the input for them. So by doing that, it's going to convert the type into the simplest possible way to explain your data. So that will be the integer rather than double in this case. And now you can essentially do the same thing. If you want to separate both two columns, you want to separate the intensity both column and also the feature column, because remember we talked about the feature is composed of the peptide first charge state and fragment and the product charge state here, and they are separated by the underscore. So you can actually, again, to use the separate function to essentially to separate this feature column, to separate the feature column into 4 columns here. So in some situation, it may be very meaningful for some people if they want to essentially to look at, specifically what precursor ion or the fragment they when they design or they will try to analyze their data. And here's one more function I want to discuss. So we talk about how to separate one column into multiple columns. So there must be also be a way to combine multiple columns into one single column, and that's what the unite function is going to do for us. So essentially, it's very similar syntax. So when you code a unite here, so you will say what would be the columns that I want to combine together. So what would be the column? What will be the column name after the combination? So here, in this case, after this separation, so we may want to combine the Z1 fragment and the Z3 here as a column called transition. It's a SRM data. So those three actually represent the transition. So we can combine three of them into a new column called transitions, and also specify those three columns that you want to combine. And again, give a separator that would place the separator between the variable in the three column. So let's take a look at the result. So essentially, you combine the variable from the Z1 and fragment and the Z3 as the transition column. All right, so that's what I want to talk about for the Tidyr. So we have four functions: the gather function, spread, and separate, unite. So any question for that?
Is there any time that you wouldn't want to read it in the table?
You don't want to data in the table?
Yeah, is there any instance of that?
Yeah, sometimes. So for example, one example I can think of would be there are some specialized R package or the function that will not design for Tibble for whatever reason. For the implementation convenience or the efficiency for whatever reason. And many of them, they are actually with very good performance. And if you want to use those packages, for example, Lima, so many data structure that Lima would use is actually not Tibble, not data frame. So in that kind of example, and if you really want to use those two or those package, then yeah, so you may want to, you have to use the data structure that they are designed around.
If you have more than one separator in one column, can you just change this? Do you just change the separator operations, or?
You mean so you have multiple possible separator?
Yeah.
Yeah. So I think you can set it in a way by setting up the regular expression. Yeah. So you may have multiple possible separator. So you put in one string, then you can do the thing for you. Yeah. Okay. So now we know how to use the Tidyr to tidy up our data. So the next thing I would like to talk about is some method in Dplyr. So Dplyr is a package that help manipulate and transform tabular data. Again, tabular data here. So roughly speaking, they can be categorized in few patterns. So the first one will be the first two functions I will talk about will be the function to reorganize your data set. So essentially, it's not going to change any content in your data set, but the first one will be to rename your column in the data frame. So it's not going to change the value in that column. It's just going to change the column name here. And in some case, you may also want to reorder your observation based on certain column. For example, you may want to order the row or the case based on feature intensity. So we'll use the arrange here. And there are few other functions specifically for manipulation and transformation. So we may want to do the subsetting of in terms of the variable. We may want to extract certain variable, or we may want to just extract existing case or observation by using filter. And for example, if you do some operation, for example, log transformation, and we want to add back to the original data frame, so we can also add new variable by doing mutate. And finally, we can do the group summary by using the summarize and group by the function that we'll be discussing now. Okay, so let's first look at the first category here, the function to reorganize the dataset. So the first one I want to talk about is the rename function here. So it can be, I think it's quite easy to understand. So here the input dataset, let's go back here. The input is again the twin DIA here. And let's say we want to rename the two column here as INTYH and INTYL. So we just provide the new name on the left hand side of the equal sign and the original name on the right hand side here. So that would rename the intensity H into INTYH, and similarly for INTYL. And the second function is arrange. Essentially, we want to reorder the row, the case of observation, based on the value in certain column. So here, for example, we want to do the arrangement based on protein and run and the feature. So you'll see the row now is arranged or ordered based on proteins, and within each protein followed by the run ID and then feature. And in some case, you may want to, so right now, when you do the arrange here, you would order your rows in the ascending order. And if you want to do the ordering based in terms of descending order, then you just provide this DESC. So that's a help function we provide by Dplyr here. So say here, we want to order based on the column subject here from high to low. So you just provide this DSC here.
Question. Can we do order by some customized order? So for example, I have a predefined order I want to see. Is it possible?
So what?
For example, I have some clustering result. I want to some observation we cluster together and see them together. So I can give a list and show which one I want to do first and which one the second. Is it possible to do that?
So I think the order function here, the arrange function here is do the ordering based on the order of the string, order of the value. So if you want to use the arrange function to do the ordering for you, then well, you must specify your value accordingly. Another way to do that would be to use vector, to save your vector and then to assign the order of the level of the vector.
So I have a vector and I give the some index for the vector, and then use this index to sort it.
Right.
Array.
Mm-hmm. Okay, now I want to talk about the second category of the function in Dplyr, which is to manipulate and transform your data in a single data set. So the first one in this category I want to talk about is the select function. So the select function, well, we can use the select function to extract existing variable. Now, for example, if we want to select the column protein and the feature column, we can just again use the pi operator to pass on the input and then to select the protein and the feature column here. And just like what we did for the getter function, we also have multiple ways to define the selection process. We can also say we want to do the selection. We want to select everything except for the pair column. So that would essentially to exclude the pair column here. And again, you can do the selection by the range. You can say I want to select everything from the column feature to the column intensity H. So you select everything from the feature to the intensity H. And this operation is actually quite helpful when you want to create some type of lookup table, for example. So you can say, I want to select the protein and the feature here, but I also want to know what's the unique set of the feature and the protein in my data set. So we can first do the selection here and pass on the result to the distinct function. That would essentially do the same thing for the unique function that we talked about yesterday. So that would take the unique set of the protein and the feature in your data set. And the shortcut for what we just talked about will be, so you can just pass on to the distinct function with the column that you want to select here, protein and feature. So that will do the same thing for you. And there are also some useful function that you can code inside select. So I did some of them. So you can actually, if you can either to code a help page or to take a look at the website of the Dplyr to see what they are meant for. So I'll just talk about two of them that can be quite helpful. So for example, we can use, when we call the select, we can also use the content function that would essentially to select all the column where their column names contain here intensity. So that would select the two columns that contain intensity here. And
Is this case sensitive?
I think so. I believe so. Not sure if you can see it here. Let me go back to this one. Yeah, so you can say, well, so I think the default is case insensitive. So it ignore case. The default is to ignore the case. Yeah. Yeah, but well, if now you want to make it case sensitive, then you can. Yeah.
Can you do regular expressions?
Hmm?
Can you do regular expressions?
Yeah, for sure. Another thing that can be quite handy would be, say, for example, sometimes when you print out, when you print your result on your console, and say, for example, you want to have this column that show at the first place or some other column, then you can say, I want to have my run column in the first column, And at the same time, I also want to get everything other than the wrong column and place in the same order. Then I can say I select wrong here and everything. So that will place a wrong here, and so all the rest of the column.
Can you do that with the name to like reorder your entire data frame? Like, just list the order you want it in and have it to select, and then it'll just change it to that order.
What?
So if I wanted it run feature protein,
Right.
like random order, I could just pass that to select and reorder it that way.
What do you mean by random order?
Like change the order of the columns so that I had run first, and then I had feature.
Oh yeah.
So you don't just need it. It doesn't just take one argument.
No. So you can say, yeah. So you can say, let's say, wrong and pair. Yeah. Okay. So we can use the select function to select a subset of the column, and now to select the subset of the row, which is our observation in the tidy format, we can use the filter function here. So for example, here we want to show those observations where the heavy intensity contains only valid value, so non-NA. So we can do the filter here based on this logical operation. We want to make sure everything in our subset in the heavy channel, all of them they are valid value, so there's no NA anymore. And for sure, you can do the same thing. You can do the filter followed by, you can do the filter for the observation and also followed by the selection of your variable. So that would do the filter first and select a 4-column here. And if you want to combine multiple logical operations, they can be separated. So you can use a command to separate them, and then the operation essentially to take an AND operation. So you filter for this condition and also for this condition. Essentially, by doing this, you extract your case where the intensity, the heavy intensity is NA, and the light intensity is not NA. Yeah, so for sure. So everything you learned previously for the logical operation can be applied here. And I will just talk about one function that can be quite handy. So I think there are many cases that you may want to just extract the subset of your data based on some intensity value. For example, you may want to say, I only want to look at the intensity between 1,000 to 1,100 here. So you can either say, okay, I would do the filtering for is greater than 100 and less than 1,100, and you can use between here. So essentially, it's essentially a shortcut for the between x left and right would be a shortcut that for s greater than this left hand side and the less than this right hand side. So that would essentially to extract the row with intensity L greater than 1,000 and less than 1,100 here. Yeah, so that's one thing can be quite helpful. Okay, so the next function I want to talk about is the mutate. We'll use the mutate to add new variable. So here mutate would use the window function. What the window function means it's a function that would take a factor of variable as input and then to return another factor of the same length. So for example, for log transformation, so you would take that can be a factor of the value, and then you would take the log transformation for every element in that factor with the same length. So those window function can be combined with the mutate function here. So just one example as I just described, you can say, okay, for this input data frame, I want to do the mutate to create one new column which has the value as the log2 transformation of this intensity L column. So that's going to create one more additional column here. So after doing after applying this mutate function, so what do you think of whether or not in this original data frame we have one new column? Are we going to see a new column here? No. Right, because by doing that we haven't really assigned the output to this object. So it's just do the operation here, but we did not save the result. So if you want to add a new column in your original data frame, so you will need to do the assignment here. So for example, you will need to assign the result, and then you'll see a new column here. And you can use the mutate function and to get those results on the fly. So what I mean is you can say, for example, you want to do 3 operations at the same time. You want to do the log transformation for the heavy intensity, for the light intensity. And you also want to get the difference between the light and heavy. So you can put them together into one mutate code here. But as long as so you first get the log2 transform for H and L, then you can use the result right away. Right, so that would give you 3 additional columns here. Right, there's again some few useful window functions. So I'll just go through them very quickly. So one is called record. So for example, in this case, we want to recode the info in the zygosity column, and we want to essentially to rename from this MZ as the monozygotic and the DZ as dizygotic. Then we can use this recode function. And there are also some other situations where you want to long up multiple categorical value into a single one, or you want to set a range of the intensity value into, say, you want to say as the low intense peak, high intense peak, etc. Then you can use the case when function that essentially is a way to factorize the multiple if and else if statement. For example, here, if we want to say for those intensity less than 1,000, we'll call it a slow intensity. Between 1,000 and 30,000 as mid intensity, and this part's high intensity. Then that will create one additional INTY category column here for you. So the last thing I would like to talk about in this section is the group by and the summarized function. That's we can use we can use a combination of those two functions to make a group summary. So the summarize function would use the summary function that take a vector of value as input and return a single value as output. So that's different from the window function we talk about. In window function, after applying the function, we'll return a vector with the same length. But the summary function here will return just one single value. Say, for example, you provide a vector of some value. You can do the average or standard deviation of those values. So you'll get one single output value. So those are mean function or the SD function. They are summary functions. And group by this group by function would actually to define the unit of analysis that you want. For example, when we do when we try to calculate or compute the median intensity per run, then we can define the unit analysis as a run, and then to do the summary, summary by applying the median function. Now I will talk about. I will just use this example to talk about the concept. Now the first thing I would do would be, I don't want to add any grouping information. So in this data set, the twin DIA data set, so I would just want to know what would be the average intensity for the light channel, and also standard deviation of the intensity and the median intensity. So I will pass this input to the summary function, and with the 3 operation here, I will first take the mean and assign to the intensity AVE, etc. So that will give me a table with 1 row with 3 columns for average, standard deviation, and the median. And I think things get more interesting when you combine the summary function with the group by here. So that would define the grouping information based on your run ID. So after the group by and summarize, that's going to compute the average, standard deviation, and median for each group. So now you can see the result here. We have the average intensity, standard deviation, the median for run 1, run 2, etc. So that would essentially to do the split, apply, combine approach just with the group by and the summarize. And we talk about to adjust the median intensity in all run to do the global normalization. So the very first thing we will need to do is actually to calculate the median intensity in the heavy channel. Now, what we can do for that would be, the first thing we'll need to do would be we will take the log2 transformation for the intensity in the heavy channel here. So that will add this one, and then we'll do what we just learned. We'll group by runs, and within each run, we'll calculate the median of the log2 intensity in the heavy channel, and we want to ignore those NA value, and we will restore the output in the column called log2 intensity mid. So that return the table with the 232 rows. That's essentially the number of runs in our data set, and also we have one column that shows that shows the median intensity in each of the runs.
What does the group function do to like all the densities for each feature? Like, so on, like, average them and like add them all together?
That depends.
Feature, you're pulling intensity, right? So whereas you're grouping by run, so what does it do with each individual intensity for each feature?
Depending on what you want to do. So for example, when you code the mean here, that would do the average. When you do the median here, that would take the median of those intensity.
Yeah, but when you do the group by run, what does it do with the intensity values for each feature?
Right. So essentially, that would, let's say, if we want to do the median, that would take every intensity from, let's say, run 1, and then do the median for run 1, and every intensity from run 2, and do the median for run 2.
Can you use the group by function without the summarize function?
Without the summarize function, then the question will be, so why you want to do that? Because
I think that's great.
Yeah, you can use group by on its own. It doesn't really do anything except returns a data frame that has groups in it. So then if you do like summarize later on, it'll obey those groups. But on its own, group by doesn't really do anything except add this idea of groups to the data.
I think it haven't really done the splitting. I think it's just add a grouping info. Yeah. So the last thing in this operation will be, so now we know already the median intensity in all the runs. So the next thing we'll need to do will be to compute what's the adjustment value for each of the run. We want to adjust those median intensity to essentially the median of the median in all runs. So we'll do it essentially on the fly. So after we get this summary, so we will get the adjustment value based on the difference between the global median and the run level median. So that essentially means in run 1, we need to, for all the intensity in run 1, we need to add this adjustment value for run 2, etc. So if we go back to here, so right now we already achieved this step. We know already in every run what's the median in there, the median of the heavy intensity in every run. And we also know in order to equalize their median intensity, so what's the adjustment value we need to apply. So we can apply this adjustment value to all the feature intensity, both heavy and light, for every run to do the equalizing median normalization. And to do that, we'll need to have a way to get this info back to our original twin DIA dataset. So I will talk about the way to merge this information back to the original dataset in the next section. Right. So that's all for this one. So, have a question before we take a break?